For decades, the United States has been at the very forefront of medical research. But now, the Trump administration is cutting billions of dollars in funding for universities, hospitals, and other scientific institutions that carry out that research. And our next guest knows all too well how vital all of this is. David Liu, a biochemist and biologist, invented two exceptionally precise gene editing tools. That's now offering hope for untreatable cancers, as he tells Walter Isaacson.
Thank you, Christian and David Liu. Welcome to the show.
Thank you for having me.
I was just out at the Breakthrough Prize, the Great Science Prize, which you won, and you did it for an evolution of what's called CRISPR technology, the technology that allows us to make cuts in our genes and edit it. And you've invented something called prime editing and other things. Explain what that is.
Yeah, that's right. So base editing and prime editing is the work that our lab developed that the Breakthrough Prize recognized. Base editing uses the wonderful targeting mechanism of CRISPR, the DNA search mechanism of CRISPR, but instead of cutting the DNA, base editing literally rearranges the atoms on one DNA letter to become a different letter. And so we can make very precise changes in the sequence of DNA, changing an A to a G, for example, or changing a C to a T.
But base and prime editing allows us to do even more, right?
Yeah, that's right. So prime editing works differently. It also uses the targeting mechanism of CRISPR, the search function of CRISPR. But instead of doing chemistry on an individual DNA base, prime editing does a search and replace on the genome. It literally makes a new segment of DNA and then replaces the original DNA segment with that new segment. And so it's very versatile. You can make any small insertion or deletion or single letter swap or combination thereof.
Tell me about how this research could be used in cancer treatments.
Well, you saw in the Breakthrough Prize ceremony a heart-wrenching testimonial from Alyssa Tapley. This is a remarkable young lady in the United Kingdom. She was 13 years old when she was told she was going to die, in her words. She was a T-cell leukemia patient who was treated with a base editor. In fact, Alyssa Tapley is the first human, will always be the first human ever treated with a base-edited therapeutic, one that uses our laboratory-evolved molecular machine to rearrange the sequence of individual DNA letters in cells that ended up clearing her cancer. Alyssa Tapley is alive today because of base editing and more accurately or more broadly because of the whole nature of the scientific enterprise. And of course, there are many, many other patients whose lives have been transformed for the better thanks to these technologies. There are actually at least 19 base editing and prime editing clinical trials that have begun. And at least 6 of them now, to my knowledge, have read out. And in all cases, all of those readouts have shown benefit to patients as a result of the gene editing.
You, your lab, your colleagues are pretty prolific because you just also published something that involves an infant being treated and potentially cured of a genetic disease. Explain that one.
So this is work led by the lab of Kiran Musunuru and Rebecca Ahrens-Nicholas and other coworkers. So first, have to give credit where credit is due. But they really achieved something remarkable in collaboration with many scientists, including our lab. And that is a newborn was diagnosed with a severe genetic disease, one so severe that about 50% of babies with this disease die in the first year. And what they did was go from DNA sequence, so genetic diagnosis, to creating an animal model, making the cells to test potential base editing treatments, developing a ton of custom base editors designed to correct that patient's mutation, testing all of it in animals, eventually in non-human primates, and then manufacturing the drug and dosing the patient all in a span of 7 months. That, for those of us in therapeutic science, is absolutely mind-blowing because everything I just described traditionally takes maybe 7 years or even longer. To do it in 7 months, when the stakes are high, because like many genetic diseases, this is one that progresses and harms the patient, gives them brain damage very quickly over time, puts their life at great risk. To do all of that in 7 months is unprecedented. So it's the first time a custom gene editing drug was developed and given to a patient. And of course, it raises the possibility that maybe in some cases, we can do this for other patients, for other genetic diseases, because these gene editing drugs are programmable.
All of these things grow out of basic curiosity, science, research. Tell me how important basic research is.
So basic science means understanding how the world works and then using that knowledge to allow us to improve society, to benefit patients, to make better drugs, for example. And that is really an essential take-home lesson here, that all of basic science gives rise to all of the reasons why investment in science is so important: the life-saving medicines, the economic impact, the highly multiplied investment in science that returns several dollars for every dollar invested, U.S. competitiveness for those who want to make sure that the U.S. remains the preeminent basis for science and innovation. And of course, training young scientists, the lifeblood of the whole ecosystem. All of that ultimately comes from supporting science, and in particular, supporting basic science.
So you talk about the importance of supporting basic science, and that goes back 80 years in the United States. Right after World War II, a system was set in place by Vannevar Bush and many others to say, we're going to fund, the government's going to fund basic research, but do it at university labs and then allow it to be commercialized. And that gave the U.S. a lead in the past 80 years. Is that being threatened now?
It's certainly in more jeopardy than I've ever seen in my 26 years as a professor, and I think that many of my colleagues have ever seen in their careers as well. You summarized it beautifully. A crown jewel of our government, a crown jewel of the investment of taxpayers has been to support science and the advances that come from science, which have saved millions of lives, have driven economic growth in our country and in other countries, have increased the efficiency with which we can do many things that are important to us in industry, in just life as a citizen, have increased our ability to operate while minimizing damage to our environment, have addressed energy crises, not to mention just basic things that we take for granted now that have dramatically extended human life, like don't eat trans fats. Just about every aspect of what we know currently to help maximize the quality of our life and the length of our lives has ultimately come from science, and much of it from United States federal support of science, paid for by taxpayers. And I think taxpayers deserve and would want those benefits to continue.
Wade, you talk about taxpayers paying for it, but then people commercialize it. Let me just take your lab as an example. When you do basic research, do you keep it proprietary, or does everybody in the world, and certainly taxpayers, get to benefit from it?
Yeah, we publish everything. We open source everything. So as soon as we believe that the work has been rigorously tested enough and reproduced enough and tested in as many contexts, and we have at least a basic understanding of something we think is really useful, like base editing or prime editing, we publish it. And not only do we publish it, we put the DNA blueprint that allows anybody to use it for nonprofit use in a nonprofit library of DNA blueprints called AdGene. And AdGene tells us that thus far, about 30,000 times, researchers from all over the world, thousands of labs around the world, have used those DNA constructs from this library of our research. So we want the public, not just in the U.S., but everywhere, to benefit from these advances, because after all, we're all on a shared mission to improve the quality and length of human life. And we believe that since taxpayers funded our research ultimately, or the vast majority of it, that the taxpayers should be able to see the fruits of that research.
One of the problems that you mentioned is that we're now cutting back drastically on federal funding for research, whether it's the National Institutes of Health, National Science Foundation. There's also a more specific issue, which is targeting some of the research universities, including Harvard, with which you're affiliated, where you teach. Places like that have been targeted. It seems to me that when that targeting is done, the people who really get hurt are the people doing medical research, and especially the students and grad students. Have you seen that these cuts mean that people have to be laid off when they're doing research?
Absolutely. It is just one of the biggest tragedies I've observed in my professional life, that because of these cuts, not only are grants just being immediately terminated, so the amount of funding that you have to support a graduate student or a postdoc or a research sample or an animal study or a clinical trial sometimes suddenly goes to zero. But students are now being told that there is no way we can pay you. So some of my colleagues have had to cut the researchers, the students and the postdocs in their labs. We have also seen students and postdocs that were bound for our university now say, well, I can't really come here because I'm worried that there isn't going to be a mechanism by which I can safely do my research and my training uninterrupted. There's a lot of worry, of course, from international students that make up a large fraction of the research people that drive this enterprise. You know, these are some of the very best and brightest people from all over the world, and they used to be selected on the basis of their excellence to come to the United States because that's where they believed the best science was being done. Now we're having candidates that have, in some cases, already accepted positions in the United States say, I'm sorry, I can't do that. Looks like there's too big of a risk that because this university is being targeted or because the research that supports the field that I'm in is being cut, that I am just better off in another country.
So we're going to have a brain drain. We're going to have a brain drain from the United States because of this?
It's already taking place. It's not a matter of there will be. I'm already seeing it in real time, and others are as well. This is not just a student issue as well. You know, base editing and prime editing, the gene editing technologies that we just talked about, those were developed in my lab in the United States, funded largely by US taxpayers. There are currently more clinical trials using base editing and prime editing in other countries, including China, than there are in the United States, despite the fact that these were United States inventions.
So you think China could now surpass us in gene editing because of these cuts and the targeting of Harvard and other universities?
Not just in gene editing, in lots of fields of biotechnology and biomedicine. China is already premier and in many respects is already passing, if not already passing, the United States. This is a time we really should be doubling down on our investment of science in maintaining the U.S. Innovation, the strength of the United States science research. And instead, there's just a culture of fear, a culture of doubting whether the United States is the best place where our most talented students should launch their careers. And it's heartbreaking to see, frankly.
Can it be reversed? Can we recover from this?
Well, the good and the bad news is the generational time in science is short. I became a professor 5 years after I was a graduate student, and it can be a very short cycle time. The downside of that is that we will feel and are already feeling the impact of these cuts and of the loss of student confidence in United States science. And that will happen, continue to happen for the next several years, even if all of the current policies are reversed. But the bright side might be that as long as there's a continued dialogue with the government and with science institutions, and hopefully one that ends up supporting a more productive path forward, that the damage can also be changed quickly.
Well, let me get this straight. The attacks on universities, including Harvard and Columbia, where you, Sam Sternberg, places like that, were done for very political reasons, and we can debate those later. But the people who got hit, you're saying, are not just the university, it's mainly the researchers, because that's where the money's getting cut. So it's research in science that's taking the hit for the political fight against universities.
It's mostly young students and young faculty members who, ironically, for better or for worse, are among the least political people in this country. These are people who have decided to forego higher salaries, easier work hours. They've made a conscious decision to use their gifts and their talents to do something that is not known for making them wealthy or for giving them an easy life, to be a scientist at a university. And these people are not politically motivated. Very few of them are political activists, for better or for worse. They just want to make a difference by using their abilities, their dedication, their love for science to advance science and technology into some kind of societal benefit. That's the common philosophy we all share. And sadly, those are the people who are being hurt the most by the current situation.
We've talked about the attacks on science from many different ways. One is the cutback just in general of research, National Institutes of Health and Science, National Science Foundation. The other is targeting universities where the research is done. And then there's a third, which is sort of what's happening in be it the FDA or Health and Human Services and Surgeon General of questioning the type of science we're doing. Do you think there's a way that we can change that perception of science and somehow save this 80-year system we have of having basic research lead to things that make us healthier?
I think it, frankly, is all up to the public. That's the component of society that I hold the most hope out for reinforcing the idea, proven over thousands and thousands of examples over decades, as you've pointed out, that investment in science returns manyfold benefits to society. I believe that the public should become increasingly aware of the benefits of science and therefore of the potential harm done to themselves and their loved ones if science isn't supported. And I'm hopeful that the public will say, you know, we really believe that among the various ways that government can and should change, cutting wholesale science, burning our seed corn, as I like to call it, is not maybe the best kind of change to have. So I'm hoping that, and part of the reason why I'm on this show doing this interview, is I really hope that more public awareness of science, how the science enterprise works, why it's so important to our country and to the world as a whole, that their awareness and their feelings about the topic will ultimately help put us on a better path.
David Liu, thank you so much for joining us.
Thank you so much for your interest. Thank you all for listening.